And next we have Hirosi Ooguri, who's going to give some concluding comments.
Thank you. Can you hear me? So let me start measuring time. Okay. So the original title of this session was V and V, the view and visions. But Rajesh and I thought that discussing these would be above our pay grades, and asked the organizer to tone it down to P and P, the perspective and prospect, which is what I'm going to do. And in fact, if you have been paying attention to the archive, you have seen lots of views and visions on string theory on the archive over the past 6 months, and I have laid this out on my kitchen table, and these are SNOMAS white papers. And SNOMAS, in case you didn't know, is a process of American Physical Society Division of Particle Physics community planning exercise, and they gather together about once in 10 years to discuss what's most interesting to move forward. So SNOMAS is actually the name of a village very close to Aspen, where Aspen Center for Physics is located. It's about 15 minutes drive. And this is where they first met, 1982, I think. But after that, people start meeting at different locations. Right now, this week and next week, I think, the SNOMAS groups are meeting in Seattle, for example. So these have been laid out on the archive, so it's not very useful to just give you overview. So rather than going through all this SNOMAS paper, I'd like to make a few remarks from my idiosyncratic perspective. So I think this is one of the most important papers that everybody should learn. And this is related to the lecture that Arthur Eddington gave in Edinburgh in 1927, where he said that the second law of thermodynamics is a supreme position, have a supreme position among the laws of nature. He said, if someone point out to you that your pet theory of universe is in disagreement with Maxwell's equation, then so much the worse for Maxwell's equation. If it is found to be contradicted by observations, well, these experimentalists do bang things sometimes. But if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse into deepest humiliation. So that's what Eddington said. And since we are in Vienna, I would also like to encourage you to go to the Central Cemetery and pay tribute to Boltzmann and his equation like I did. This is actually, as you can see from my attire, this is not this year, some years ago. But when you go there, I just wanted to tell you that it's very important to know where it is. So I went there twice, because first time I went there and I couldn't find his tombstone. And then, so it's in group 14C, and his tombstone is number 1. If you go to the front office, entrance office of the Central Cemetery, you can get a map. And you can also visit the various interesting things about musicians too. So I'd like to encourage you to do that. I think there is an equation here. So coming back to this equation. So the black hole entropy formula, which is this one, has inspired significant progress in string theory and quantum gravity over the decades. And its derivation by Strominger and Waffer gave us very deep insight into microscopic states of black hole and led development of powerful new techniques. I don't think anybody would disagree with this statement. But recently, people have realized, in fact, there are important corrections to this formula. And as Witten said in his lecture, the left-hand side is better defined. The left-hand side is better defined than the ether term on the right-hand side. And so if you add these two terms, actually the formula becomes better defined. And it was found to be really powerful. So for example, 3 years ago, there was an amazing resolution of the puzzle about von Neumann entropy of Hawking radiation. And this resolution demonstrated the power of the quantum extremal formula, which follows from this one. And where it was a semi-classical calculation, this was a great achievement, but I should also note that this is semi-classical calculation that is analogous to the Gibbons-Hawking calculation of this formula. And we would like to do something like Strominger buffer. And so analogous to that would be to realize a recent proposal by Chris Eicher and collaborators that Daniel Harrow presented. Daniel presented is a toy model of the situation. And so if you can do something like that in a theory related to Einstein gravity, well, that would amount to analogy of Strominger buffer calculation for the ultimate resolution of the puzzle about von Neumann entropy of Hawking radiation. So in this context, wormhole also plays an important role. And there are also other aspects of quantum gravity, such as quantum chaos, where wormhole plays an important role. So naturally, the people's interest in wormhole have been revived. But there are puzzles, like, for example, are these phenomena low-dimensional artifacts, or are they suggesting general features? And there is a question about ensemble averaging. We had a discussion session on that. So I just wanted to note the recent paper by Schrenker and Witten sharpened the puzzle on their roles. And I think that some of these generic features of quantum gravity can be relevant to address these questions about wormhole too. The absence of global symmetry, the distance conjecture, and more recently the cobordism conjecture. And these seemingly generic property of quantum gravity theory are actually closely related to each other, and there seems to be common features of all known quantum gravity theories that, as far as we know. And in fact, there is a precedent to that. This is actually a quote from Einstein's autobiographical note. This is a very interesting part of the discussion. So he actually explained what the natural unit means. And he says that when you express basic equation in natural unit, the only dimensionless constant appear in the equations. But he says that concerning such, I would like to state a theorem which at present cannot be based upon anything more than upon a faith in the simplicity, namely intelligibility of nature, that there are no arbitrary constants of this kind. So that's what he said in his autobiographical note. And there is a modern formulation of that we learn in string theory, that is every parameter in quantum gravity is an expectation value of a dynamical field, and it can be varied by changing its expectation value. Well, this seems like a fundamental fact about quantum gravity, and it would be nice to understand this, whether this is actually really true or not, and at least we can try to prove this statement in the context of ADS-CFT correspondence, for example. So how do we go about doing that? Well, let's try. So suppose there is a parameter in ADS, in the gravitational theory in ADS. There must be a corresponding parameter in dual CFT, because as you vary the gravitational theory, the corresponding CFT would vary. But if CFT parameter can be deformed by adding an exactly marginal operator to the CFT Lagrangian, then there must be a dynamical field in ADS. So this seems to be the derivation of this statement, except that this conditional clause is actually a conjecture in conformal field theory, as far as I know. That this has never been derived rigorously. So the question is that can every conformal field theory parameter lambda be deformed by adding an exactly marginal operator phi to the conformal field theory Lagrangian? And if you think about this, this is actually analogous to the Noether theorem. So Noether theorem has to do with the spiritability of symmetry charge into product when you divide the Cauchy surface into segment. And this was actually, this plays an essential role in my proof with Daniel Harrow about the absence of the global symmetry in quantum gravity. And if you think about this, this statement is actually the spiritability of -1 form symmetry in conformal field theory. So if you need something like analogous to the Noether theorem for -1 form symmetry to prove the theorem which is analogous to the absence of global symmetry, which is the absence of arbitrary parameter, that all the parameters are related to dynamical field. So there is this correspondence between no parameter in quantum gravity and no -1 form symmetry, no -1 form global symmetry in quantum gravity. And it seems like it's important to prove this statement. Related to that, I'd like to quote from Snowmass paper on the analytic conformal bootstrap that says that new methods are needed to take advantage of the vast additional data encoded elsewhere in the conformal manifold and to address questions about the manifold itself, such as whether there are universal property of conformal field theory at infinite distance. This is related to the infinite distance, the distance conjecture in the gravitational theory. So that lets me to also propose two problems in my talk. One is the one that I already mentioned. When a unitary conformal field theory has a continuous parameter, show that there is an exactly marginal operator generating its deformation. So that's problem number one. And problem number two is to find out whether there are universal property of conformal field theory at infinite distance, as this white paper suggests. And so if so, quantify this property. And I'd like to actually highlight this importance of quantifying the property of conformal field theory at the infinite distance in the conformal manifold. By the way, in principle, these two problems are independent, that even if this is false, you can still investigate this question. So I think that quantifying this infinite distance behavior in this moduli space is important. For example, one of the ways that it manifests is this Snowmass report, which is a sort of summary of all the Snowmass white paper in what they call theoretical frontier number 1, which is about quantum gravity, string theory, and black hole, summarized by Daniel Harrow, Shamit Kachiru, and von Maldacena. And this is a quote from their draft report that says that one question of great experimental and theoretical interest is whether quantum gravity can produce inflationary models with relatively large value of R, the tensor to scalar ratio. It is possible that there is a theoretical upper bound for R, and it would be very interesting to understand where it is. So when I was reading this paragraph, I was reminded of my conversation that I had with the chair of my division at Caltech, the Division of Physics, Mathematics, and Astronomy. At that time, I was a deputy chair, so I was helping out, and I was sitting in my office, in the division's office, doing some administrative work. That was in February of 2014. And the chair walked into, by the way, this conversation did take place because he quoted it very often afterward to tease me. So he walked into my office and said that BICEP 2 is going to announce that R is 0.2. And that was like a month before it was officially announced. And I said, great, it will kill string theory. And so the reason I said is sort of summarized in this diagram that appeared in a paper by Hirosi and Valenzuela. So you can see that there is a line by distance conjecture below which is allowed by distance conjecture. There is a Rice bound above which is allowed by Rice conjecture. The horizontal axis is R, the tensor scalar ratio, and the vertical axis is the amount that the inflaton traverses, and they intersect at about R equals 0.2. So that was sort of the reason that I made that statement. Of course, the important thing, which I didn't want showing this was not the point, but what I wanted to show was to demonstrate the importance of quantifying this. Because if you there is order 1 leeway in the distance conjecture, so this can easily go up and down. So that would make the location very different. And this is very important because Planck is now over here. And in the next 10 years, I think the bound can possibly go down to one notch below, like here. So then, for example, if this goes down a little bit, then we can be in tension. If it goes up, then this conjecture will be totally relevant in this context. So this is very important to find out. And in fact, this point was raised in this Snowmass paper on implication of quantum gravity for particle physics, in which they said, we'd emphasize that even in the large field inflation, where observable tensor model could be correlated with a Planck scale field space distance, related to the distance conjecture, only requires that the del phi order 1 M Planck and could be entirely consistent with this bound. So depending on where precisely this line is located can be entirely consistent, and I think I agree with this view. And so I think that it's very important to understand it, and it's trying to do it actually bringing lots of interesting problems, such as a problem of physical mathematics. So this is a quote from the draft paper called Panorama of Physical Mathematics, which is the expanded version of the Snowmass paper on physical mathematics, in which they say that when the distance conjecture is made mathematically precise in the context of Calabi-Yau compactification, some very non-trivial mathematics emerges. And for example, this morning we had a very interesting talk by Lee on his latest attempt to discuss this. And so have we already? Okay. I'm halfway through. I apologize. So this involves very interesting mathematics because, for example, in order to address the issue of finite G Newton, we have to discuss compact Calabi-Yau manifolds. And there is a big difference between compact Calabi-Yau and non-compact Calabi-Yau. There are many important questions of physics and mathematics of compact Calabi-Yau that we need stronger tools to address them. In topological string theory, for example, for non-compact Calabi-Yau, there are many tools such as the topological vertex and matrix model, which you can calculate partition function to all order in genus expansion. In the compact Calabi-Yau case, the BCOB equation can only be integrated in the best case up to genus 15. But there are very important questions, such as the question about OSB conjecture, for example, that you need to know the asymptotic form of this partition function, for example. And there are other things I wanted to say. But what I wanted to say was even this kind of very idiosyncratic perspective of my short story, concept from variety of areas showed up, black hole, wormhole, general symmetry, and the even wider range of topics is discussed in Snowmass white paper. And often if we want to work on some aspect of string theory, it becomes important to bring in many ideas. And for more than 30 years, the string conference series has been providing a unique opportunity for us to come together as a community to hear about the latest development on all aspects of string theory, to exchange ideas and to open new direction of research. So this is actually a very important thing for our community, I believe. So this leads me to the second part of my presentation, which is about the future of string conference. And I first want to say that this is not an announcement I'm going to host the Strings Conference next year at Caltech. I should say I have hosted String Conference 3 times, so I feel that I should give this wonderful opportunity to somebody else. And so I thought it'd be interesting to go over where the String Conference took place. So these are the places where String Conference took place over the last 30 years. But for the first 10 years or so, it took place mostly in North America and some part of Europe. But it gradually expanded to other parts of the world, many more in Europe, some in Asia. For example, India, China, Japan, each hosted one string conference during this first decade of 21st century. And now it has spread over even to southern hemisphere. And it's very interesting because if you count the location, then it's totally evenly distributed now in North America, Europe, and other areas, Asia, Israel, and the southern hemisphere. So this is sort of one way to measure the level of activity of string theory over the world. But there are other measures that you can measure the level of activity. One important measure is an invited scientific speaker of this conference. And it's kind of interesting to compare these two maps. And so I put them on the top of each other. But I'd like to leave, there are a few observations one could make, but I would like to leave that to the exercise of the audience. So there are various issues more seriously that we should consider. I think that the budget is big. I'm going to tell you a little bit about that. And administrative support is very important. So that is a very important thing to consider. It was also already mentioned that carbon footprint is something we should consider seriously, that we can see the effect of climate change this week in Vienna, for example. And use of the virtual space is something we learned for the last couple of years. We need to improve the diversity of this conference and, in fact, our community more. And also the conference should be welcoming to all members of our community. And we should have more support for students, postdoc, young researchers. And access from developing countries are important. And I should also point out the process to select and vet future conferences. Over the last 30 years, I mentioned, we have had the informal process of selecting host of strings conferences. The volunteers to host the strings have come up spontaneously. A proposal was made to the International Advisory Committee for Strings Conference of that year, because that is the only formal body of our community, the community that we have. And announcement was made at the Strings Conference. And many of us, including myself, thought that the String Conference, that the fact that the String Conference managed to happen every year for certain years in such an informal fashion is actually a good feature of our community. However, in recent years, this practice has been under some strain, and I think it seems to be time to update the process. So this was why I proposed to establish a planning committee for future string to the International Advisory Committee just a few weeks ago. And in fact, an ad hoc committee is being formed right now, and we have met a couple of times. And in order for the process to be inclusive and transparent, I think we need a well-defined set of charges and processes in which its members are elected, for example. But there is a problem. There is a chicken and egg quality to do it, since we do not have a formal governing body to approve the charge and the process. So I think that one way to move forward is that if our community as a whole support this idea to move forward, we can move forward in that direction. And so I'd like to encourage you actually to post your comment, your thought on it, on a Zurich chat. Fortunately, we have this Zurich chat for this conference, and I hope the organizer can leave this for a while so people can post and have some conversation on it. And so we can discuss what will be the more inclusive and transparent way to move forward, to continue these wonderful conferences. I just wanted to also say a few words about the budget and other issues. So this is actually the size of past string conferences. And this is actually the total expense and the number of participants. You can see it's about, the total cost is about $250,000 per each conference. In 2018, in Okinawa, we had twice as much budget because we wanted to sort of invite younger postdoc and students more, and we felt that bringing them to remote island requires more fellowships, etc. But typically about $250,000. But one thing to note is that last couple of years we have had online virtual meeting, and the total expenses are like 100s. But they had like 5 more people coming. So one can ask the question, well, so what's the value that we get from this kind of in-person meeting? For example, this is from my summary talk from the String Conference last year in Sao Paulo. So one of the Facebook posts from a very distinguished string theorist who said that the organization of this year's String Conference has been amazing. I have never before seen this level of open, honest, reflective discussion in a conference of more than 300 live participants. So there is some point to be made about this. So there are a few things we can discuss this, but I try to list a few things I can think of in sort of pros of virtual versus real. So as you can see from my table, the virtual meeting had 5 times participants. Actually, if you look at the live participant, it's about twice, but was able to do it in 100th of cost. And it significantly, of course, reduced our carbon footprint. And online discussion actually encouraged the participation of young researchers. So for this kind of meeting, it's great. But sometimes young people are hesitant to raise questions in the live. And so I have been hearing from people that this is actually very nice for young people. And also accessibility from distance place is great. But there are, of course, things that we cannot cannot yet duplicate at the current technological level. Chance encounters, small talks at tea time, silly questions that I like to ask to expert. These can often lead to important new insight and open new direction of research. It's very hard to duplicate in this. And of course, this also gives networking opportunities. This is another thing I hear from young people, that staying at home research activity deprives them of opportunity for networking. And I'm very grateful for the organizer this year to providing that to our community. And also, I like to say I enjoyed going out to dinner, concert, wonderful party, conference banquet, etc. This is a great opportunity to enhance our camaraderie and cohesiveness of the community, which is very hard to do in virtual. So I think there are benefit on both of these possibilities, and moving forward, we might consider sort of combining these two. And given this, I would like to announce that String 2023 is going to be hosted by Perimeter Institute, but for now, virtually, because they don't have big enough auditorium for 400 people, although they are considering the possibility of bringing in some number of people, and this is work in progress, and we are currently discussing dates that works for them as well as other schedule. I'd like to point out that we also have satellite meetings. So String Fino will take place in the first week of July in Daejeon, which is a new institute for basic sciences. I think one of the members spoke this morning in Korea. And then followed by String Mass in Melbourne, Australia. So we have a lot of things to look forward to next year. But I'd like to end with, I think I have one, and in fact, the most important thing that I need to do as the last speaker of this conference, which is to thank the organizer of this wonderful meeting. I admire their courage that after the South Africa conference went online, after São Paulo conference went online, we are still only gradually getting out of the pandemic, and having this conference requires courage, attention, effort, and commitment of everybody wearing red t-shirts and not. And I really admire their courage and determination and dedication to the community. So I think I'd like to take this opportunity to thank them. First, the International Scientific Committee chaired by Johanna. And this is something actually I'm proud of. I started this the String conference in Okinawa. And the reason I did that was that I was attending the String 17 in Israel, and it was a great scientific program. And as I was attending it, I became increasingly worried that local organizer in Japan would not be able to do that. Until now, local organizer was doing this. And this is actually one way to make our conference more inclusive and diverse and representative of all areas. And this is great. And I also thank the selection committee of Gongsho, which I enjoyed enormously with very enthusiastic chair by Irene Valenzuela yesterday. And tonight, we'll have the public lecture by Netta Engelhardt, and I'd like to thank Anton Rebhan of Technical University of Vienna and his group for hosting this. We'll also have the colloquium by Andy tomorrow at 7 at the same location. I'd like to thank the local organizing committee, many are wearing red t-shirts, for having this conference go so smoothly, and thank you so much. I would like to note there are two people from different locations. I think they were student or postdoc here and moved on. Abiram, for example, you are getting lots of email from him, I'm sure. He is now my colleague at IPMU. I would like to brag. In fact, today, 3 of the speakers are affiliated to IPMU. And so I'd like to thank all these people. And then, of course, finally, I'd like to thank the main organizer from these two main institutions that hosted the conference, Stefan and Danielle. Thank you so much. So with this, I would like to invite organizing members, Daniel, Stefan, and everybody wearing red t-shirts, come up to the podium and recognize their achievement.